Next, we are going to talk about merge sort. Merge sort is a very interesting algorithm. So it has got various things that you should note about. First of all, it is a stable algorithm. Second, we are going to use recursion to write merge sort code. Also, this is a bit optimized code than the code that we saw till now. So we saw till now the time complexity of O of n square. There will be optimization over here. Also, in merge sort, we use a concept of merging two sorted arrays into a single sorted array. So this merging concept is something that is going to help you in several coding programs that you're going to write. It's going to help you in solve those programs. So make sure you understand merge sort really well. It is going to help you a lot. So make sure you understand really well. So what we will do is that first we'll understand the concept of merging a bit. Then we will try and run the merge sort on this particular example. Then we'll see the proper code, and then since it's a recursive code, we'll try and dry run the code. So we'll try and dry run using the recursion tree. Make sure you understand that well. In case you don't understand just by watching the video, try on your own, because you have to dry run the code of recursion to understand things really well, and it is going to help you a lot. Even the next algorithm that we are going to talk about will be solved using recursion. So make sure you understand it well. So now let's go ahead. So now let's say what happens in case of merge sort. There are two things. One is that we keep on dividing the array into two halves. We keep on dividing the array into two halves, and this is the one thing, and I'll tell you till when we keep on dividing. And the second thing is that we have, at any point we will have two sorted arrays, two separately sorted arrays, and we have to merge them to form a single sorted array. So first let's just understand the merging part. Okay, so now let's say let's say this array is divided in two parts, and let's say this part and this part, and each of these part is individually sorted. So let's say this is 1, 6, 7, 8, okay, and this is sorted 0, 4, 5, 9. Okay, I hope I have sorted correctly. Okay, so now these are the two sorted arrays that I have. So now what I have to do is that I have to combine them to make one sorted array. So what I will do is that, let's say I have to combine them to make one sorted array. So let's say I have to place 8 elements. So it's 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now what I will do is that I will see which element has to go here. So I see 0 can go here, here 1 can go. So from the two arrays, I'll keep on checking that which element should go to this particular place or to the next available place, such that the final array is sorted. Then I check 4 can go next, then 5 can go, then 6 will go, then 7 will go, 8 will go, 9 will go. So this is how we merge these two sorted arrays, and I made one completed sorted array. Okay, now let's try to understand the division process. So as I said is that we keep on dividing the array into two parts, and what we do is that we try and sort the two parts individually, and then we try and combine the sorted parts to make one complete sorted array. So let's try and do that. So in this case, again, let's say initially we will have 1, 7, 6, 8, and then we will have 0, 9, 4, 5. So I just did the division. Let's say I did the division in this particular manner. Okay, so let's say this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, now what I do is that I again do the division in this particular, I continue my division in this particular half first. Okay, so now we will have this particular division, we will have 1, 7, 6, 8. Okay, now I again continue to this half, I again do a division here, so we will have 1, 7. Okay, so now what happens is that when we reach at a place where we have a single element, which means the single element obviously is sorted. So now as soon as I reach to this particular place, I have two sorted arrays. So what I'll try and do is that I will try and merge these two sorted arrays. So let's say the merge of these two sorted arrays is 1, 7. Okay, so now I have this particular part of the array that is already sorted. So now I'll go to this particular part, I'll bother about this part. So now this gets further divided into 6, 8. Again the same thing, we have two part of the array that is sorted, I have to merge them. Now we have merging as 6, 8. Now we have these two arrays that are sorted. I have to combine these two arrays. So I combine these two arrays and I get 1, 6, 7, 8. So now what happens is that after these many operations, I see that my first half of the array is sorted. Okay, now what I'll do is that I'll continue the same operation in the second half of the array. So now we had 0, 9, 4, 5. So I put a division over here. So I have 0, 9, 4, 5. I again put a division here. We have 0, 9. Okay. So now what happens in 0, 9 is that again these two arrays sorted. I combine them. We get 0, 9. Similarly here we will have 4, 5. I combine them. We get 4, 5. Now I combine these two sorted arrays. I get 0, 4, 5, 9. Okay. Now I have this sorted array. Let's call it S1 and this sorted array S2. Now I combine these two sorted arrays. We have done the merging over here. So we merge these two sorted arrays and we eventually get a finally sorted array. So this is how the merge sort works. We keep on dividing until we reach to a place where we get a sorted array, and then we keep on dividing so basically what we are doing is that we are dividing the problem into subproblems, and we keep on dividing to a subproblem unless the problem can be solved individually. Then we combine the results. So this whole thing of dividing the problem into subproblems is divide and conquer. So basically you divide the subproblem, solve it, and then the solution of the subproblem you use it to solve the bigger problem. So we will talk in detail about divide and conquer. One of the algorithm of divide and conquer we already saw was binary search. Okay, now let's just go ahead and see the code of merge sort. So first we will see the code of merging, then we will see the complete code of merge sort. We'll try and understand the merging. Though we have understood, we will just see how this thing will be implemented in a code. Okay, so now this is the code for merge sort. This complete code is merging. Okay, let's just try and understand. So what happens is that in case of merge, what we do is that we pass the array, the original array, then we pass the left, mid, right. So we saw, let me go back and see the previous array. So it was 1, 6, 7, 8, 0, 4, 5, 9. It was 1, 6, 7, 8, 0, 4, 5, 9. Okay, it's going to be 0, 1, 2, 3, 4, 5, 6, 7. So in this case, what we are going to do is that we are having both the arrays are combined in one only. Okay, there is no I'll say there is no physical separation or something like that. But what is the separator here? The separator here is mid. What will be mid? Mid here will be 3. Okay, so we have this particular index as mid. Okay, this is my left, 0, and 7 is my right. Okay, first let's just try to understand the merge part. So now what we do is that we have to put the sorted array. This is my array. Array looks something like this. I have to put this particular array in a completely sorted form. Basically, whatsoever is here and whatsoever is here, I have to combine that. So what I will do is that I will take two extra arrays. Let's call it left array and right array. So what I'll do is that I'll just copy all of these elements in left array and all of these elements in the right array. So every element from left till mid is there in left array. Every element from mid plus 1 to right is in right array. So let's see how do we do this operation till here. Okay, so now what happens is that we have here the array, we pass the left as a parameter, we pass the mid as the parameter, and we pass the right as parameter. We see how we get these as parameters. We'll see it here. Now what happens is that we calculate the number of elements in this particular part of the array. So this is going to be mid minus left plus 1. So why we are doing plus 1 is that, so what happens is that if you have to find the number of elements between two places, what you do is that, so let's say if you have to find the number of elements between 1 and 2, okay, like how many numbers are there between 1 and 2, and you have to include 1 and 2. So if you do 2 minus 1, what will be your answer? 1. But the actual number of elements is going to be 2. So you always add 1. So you do high minus low plus 1. So this is my mid minus left plus 1. So it's going to be, my mid is 3. Okay, let's calculate n1 is equal to, mid is 3, low is 0, mid minus left, let's call it left, left is 0 plus 1. So my n1 is 4. So the number of elements in the left array is 4. Let's calculate for right. So for right, it's going to be right minus mid. Why? Because I have to calculate from here only, but since what we did was that we had two options, you do right minus mid plus 1 plus 1. Okay, this is one option you have, that you do 9 minus 4, which is mid plus 1. Okay, so if you do 9 minus mid plus 1 plus 1, so let's say this is one option. So because this is mid plus 1, okay, this place is mid plus 1. So this will give you 9 minus mid minus 1 plus 1. So anyways, this will get cancelled. So we will simply do 9 minus mid. So we will do 9 minus, this is not 9, this is 7. I don't know why I took it 9. Okay, so this is 7 minus mid. So it's going to be 7 minus 3. So n2 is going to be 7 minus 3, which is 4. Okay, now let's say I come back here. So I will fill all the elements in left array first. So what I do is that I run a loop from 0 to n1 minus 1. So there will be number of 4 elements. So the index in left array is going to be 0 to 3. Okay, so it's going to be 0, 1, 2, 3, 0, 1, 2, 3. This is not required. Okay, so I start filling. So I start filling from 0th element. So left ar I equal to ar left plus I. So in this case, what is happening is that left is 0, but it might happen that left is not 0. So when we will do the complete recursion tree, we will see that there will be places when left is not 0. So what we will do is that we will do left plus I. So if we execute this, eventually my left array will get filled with these values. So it will be 1, 6, 7, 8 will get filled in left array. Similarly, right array will be, this particular thing will get executed, and my right array will be 0, 4, 5, 9. Now what I have to do is that I have to execute, or I have to combine these two. So now this particular part of the array, this particular part of the code is doing the task of combining these two arrays. Let's see how is this happening. So first of all, we have a condition that while I is less than n1 and j is less than n2. So we will keep on running this particular loop only till we have element in both the cases. So let's say what happened is that we just exhausted all the elements of left array, and there are still elements remaining in right array. So what will happen in that case is that, let's say this is my final array. So it's going to be 0, 1, 2, 3, 4, 5, 6 and 7. So let's say I added all the 3 elements from left array to this particular part of the array, and this is remaining. So what I'll do is that simply I'll copy all the remaining to this particular array. Okay, now let's just go ahead. So what is our idea is that I will keep 2 pointers. Let's say, actually I'll keep 3 pointers. Let's call them, I'm calling them here I, j and k. So let's call them I, j and k. So what is I here is that basically I is keeping track that which element from this left array should go here, j is tracking that which element from right array should go here, and k is tracking that at which particular place I am filling the element. So what I'll do is that I'll compare that which of value of left array I and right array I, whichever is smaller. So whichever is smaller will go here. So initially my I is 0, k is 0 and my j is 0. Okay, so now what we do is that we check for I and j. Here what we check is that if whichsoever is smaller, I'll just put that one in k and I'll increment that particular index. So in this case what happens is that a of right array of j is smaller, this is 0. So what I'll do is that I'll put 0 here, I'll increment my k comes to this particular place and my j comes to this particular place, my I remains as it is because I haven't taken the element of I. Now what happens is that I'll compare this element and this element in this code. Again, this particular part of the code is doing that. I compare this and this. Again, in this case, one is smaller. So what will happen is that this I1 gets executed. So this particular gets true. So this one gets executed. So I put 1 here. Okay. Now I increment my I. So my K and I both are incremented. Now K comes here. My I becomes 1. Now J is 1, I is 1 and K is 2. Okay. Now again what I do is that I check between 6 and 4. Which is smaller? 4 is smaller. So this particular condition becomes false. This else gets executed. I put 4 here. Now my J gets incremented and goes till here. K gets incremented and goes to here. Now I compare between 6 and 5. What will happen is that again 5 is smaller. So I'll put 5 here. My J gets incremented to this place. Okay, and my K gets incremented to this place. Now what I'll do here is that my I was here, right? So I compare 6 and 9. 6 is smaller. So now I'll put 6 here. K gets incremented here. I gets incremented to 7. Again from 9 and 7. 7 is smaller. I put 7 here. K gets incremented here. I gets incremented here. I put from 9 and 8. 8 is smaller. I put 8 here. And now what happens is that as soon as I put 8 here, I increment my I. So when I gets incremented, while I less than n1, this becomes false. So we come out of this particular loop. Now what happens is that when we come out of this particular loop, we check. There are two conditions that, either all the elements from first array has got exhausted or all the elements from second array has got exhausted. So I check that if there is any element left in the first array, I is less than n1, which means there is still element left in the first array. In that case, I'll simply copy all of this to here. But that is not the case here. This is the case. J is still less than n2. So in that case, we will simply copy the remaining elements to this particular element. So I just copy 9 here. So this is the process of merging. Okay. So now this process happens multiple times in the whole merge sort process. So we will see that when we go ahead and talk about the recursion tree. So let's just see the crux of merge sort over here. So what happens in case of merge sort is that we calculate mid. So we keep on running this. We saw that we stopped our merge sort or the process of dividing when we found a single element. So there is no further division that could be done. So this is one case. Another case is that if at any point left becomes greater than right, which is not a right scenario. So in that case also merge sort will not go ahead. Okay. So now we check that if left is greater than equal to right, which means we are either left with a single element or there is some invalid condition we have got into. In that case we simply return. Okay. If that is not the case, what we will do is that we'll calculate mid. Okay. Now we will call merge sort in the left part. So we have left comma left mid. So our left gets this value and my right gets our mid. Okay. Right gets updated to mid. So basically the division part that we saw. And again what we do is that we also put merge sort in the second half of the array from mid plus 1 to right. And whatsoever result we get, we do the merging. Let's just go ahead and what we do is that we will just, for this particular part, we will go ahead and make the recursion tree and let's try to understand this even better. Hope you have understood the merge process. If you haven't understood the merge process or there's any sort of confusion, I highly recommend stop this video, do on your own, because many things you understand when you start doing on your own only. Okay, so make sure you do on your own. Just stop this video, try and do it completely on your own with the concept you have understood. That will help you to a great extent. So let's go ahead. Now let's go ahead and dry run this merge sort code. So we have already seen the merge process. We will just see how the array is getting subdivided into parts, each time by half, and how we eventually start, coming back and start merging the elements, the parts of the array. So that is what we are trying to understand here. So what happens initially is that this merge sort gets called by the main function. So main will pass left as 0, which is this particular index, and right as 7. So from here the function call or the recursion just starts. So let's say we have first call as ms07. Let's see how things go further. So now what happens is that we will calculate mid equal to 0 plus 7 by 3. It's going to be 3. So now I get my mid as 3 here. Now what will happen is that I'll make a call. Okay, now my call is going to be, what will happen is that I'll make this particular call, merge sort ar left mid. So what is my left? My left here is 0. What is my mid here? Mid here is 3. So now again this particular function comes here. What is the value of left now? 0. What is the value of right now? 3. Okay, now we check this particular condition. Is this true? No. So I again calculate my mid. So here my mid becomes 1. Okay, now I'll go to this particular line. This particular line again gets executed. Again we have a new function call. Let's call it again ms 0 comma 1. Why? Because mid was 1. So ms 0 1. Okay, I again calculate my mid. My mid becomes 0. So now what happens is that I come here, I check left is greater than or equal to right. No, I calculate my mid comes out to be 0. Now I again call this function. So from here we call ms 0 comma 0. Now what happens is that again from ms 0 comma 0, let's say left becomes 0, right becomes 0. We check if left is greater than or equal to right, if this condition is becoming true. So since left is equal to right, so there is no further calculations that happen. We just go back to the returning function, go back to the calling function. So what happens is that as soon as we get ms 0 comma 0 here, we come to this particular line. So whenever this particular function just finishes execution, we go to the next line that has to be executed, and we execute that line. So now let's say my mid was 0 here, right? So here when I call this particular function mid merge sort 0 comma 0, here my mid was 0. So now here what will happen is that now ms 1 comma 1 will get called. Again same thing will happen, left is equal to right, so we simply return from here. So now we return from here. Now for the value of left as 0, right as 1 and mid as 0, this particular line will get executed. Now merging will happen. Let's call it MER. Okay, now this is 1, this is 7, and the merging will give me this part of the array 1 7. Okay, now after this thing happens, what will happen is that we will again come here and we see that there is nothing more to get executed, so we will just return. Now when we will return, what happens is that the execution goes in this particular way. We execute this, then we execute this, then we execute this, and then we go back and see that if there is anything that is remaining. If anything is not remaining, what will happen is that we will come back here when the value of mid was 1. So basically now this particular part will get executed. So we come back where the value of mid was 1 and left was 0 and right was 3. So here this particular branch has completed the execution. Now we will come here, we will call ms mid plus 1, which is 2 comma 3. So now what will happen is that here further execution will go on. So here my mid will be 2. Okay, let's calculate it normally. 2 plus 3 by 2, it's going to be 2. Now here we will have the function call. So the first call is going to be, my left here is 2, my mid here is 2. So I'll call merge sort 2 comma 2. So this is ms 2 comma 2. So now what happens with 2 comma 2 is it's a single digit, only one number in the array. So I return from here. Okay, what is my 2 comma 2? It is 6. Now we come back here. So now what happens is that mid plus 1 comma right, this particular line gets executed. So we have mid plus 1 as 3, right as 3, so ms 3 comma 3. So 3 comma 3 is, what is 3 comma 3? It is 8. So now what happens is that after this particular statement gets executed completely, this particular function returns. What happens is that we come here and we merge. So now here when we merge, we get 6 comma 8. Okay, so now this particular thing has been executed completely. This particular branch has been executed completely. Now we come here for our left equal to 0, mid equal to 1 and right equal to 3, and now merge will happen. So here now merge is going to happen. Okay, now merge is going to merge which two particular arrays? It's going to merge 0 1 and 2 3. So basically it's going to merge 0 1 2 3. Yes, so now what we will do is that mid is 1, I'll follow the same merge process, and here when merge will happen, our array will look something like this. We will merge 1 comma 7, 6 comma 8, and we have seen the merge will give us 1 6 7 8. So now after this merging happens, we see that all of the branches are executed. We go back. Okay, we go back here. Now what we do is that our mid was 3 and we see that there is nothing to be executed in this particular branch. Now we come back here, and for here now my value of mid is 3, my left is 0 and my right is 7. So now a new branch will execute from here. It's going to be ms, mid is 3, so now mid plus 1 is 4, so it's going to be 4 comma right is 7. So now similar process will keep on happening, and this is how we will now, what will happen is that just like this branch occurred, all of the elements of this particular branch will occur, and what will happen is that from 4 to 7 we will get a sorted array. So by the time this particular branch is completed, we will have this particular part of the array sorted, which is 0, 4, 5 and 9. And now once that has happened, again we call merge here. So we will call here merge from 0 to 7 with the mid value as 3, and after this merge we will get a sorted array which is going to be 0, 1, 4, 5, 6, 7, 8, 9. So this is how merging happens. So make sure you dry run the code on your own as well, because when you will dry run the code on your own, that is when you will understand. Always remember, in dry run there are two ways that you either, what you do is that when you do the general way is that this is how the branching happens. So there's one particular part, then the one particular part is there, then all the part of that particular part get executed, then we go back and see what is remaining. So always remember that generally what happens is that we see it from top, okay, and we think that all the three processes happening parallelly or what. We don't understand the sequence in case of recursion. Once you understand the sequence and you understand that what happens when a particular function that is being called has done its execution or it returns back, so what happens next, if you understand that, you will understand. So make sure you understand this code on your own. At any part, if you don't understand, pause the video, see the video again, but make sure you dry run on your own as well, okay. So if you see the time complexity, okay, before I was about to finish the video, then I remembered I didn't tell you the time complexity. So if you see what is going to be the time complexity, let's see the time complexity. So the time complexity, can we write T of n is equal to, every time I am dividing the array into 2 half, okay, so it's going to be T of n is equal to T of n by 2 plus we have n time for merging of the array. So we divide the array into 2 parts, so you can write it 2 into T n by 2 plus n, okay, and this is the equation, and if you solve this equation you get the time complexity of n log n. This is the time complexity of merge sort. Okay, this is the worst case as well as best case time complexity. And what is the space complexity? If you see, we are using extra space O of n. So this is the space complexity of merge sort. Okay, so make sure you understand this merge sort really well, the merge process, the division process, and then things will be really easy for you. Okay.